Yeah, camps on everyone. Let's start off. Perfect. So last thing that we did, we have finished with vectors, right? We did vector dot product, scalar dot vector cross product, box product. That was the last thing that we did. Today we'll be starting with a new chapter, calculus for physics. Again, this is not exactly a physics part, but the mathematical things, right, that are important for physics. The thing is, they will teach you calculus in max next year around March or April. It will be too late. So again, let's be very clear. We are not going to do everything in detail. Our main purpose is to get the basics right so that we can use it for physics. So certain things we'll not ask how we got them, why we got this. So we'll just accept it like, okay, that's how it is. Let max people take care of the derivations later on. Okay, so let's start off. And yeah, if your cams are not on, I'll be removed from the classroom. So I won't keep telling you this thing n times. Mm. And Dhruv, your cam every time, yeah, just make sure it is on. It becomes dark for some reason. So yeah, so yeah, okay, let's start off. Just give me a minute. Let me just check the attendance. Okay, great. So let's start off with something. First thing is your functions. Again, we will not get into the whole detail about it, but what is a function here? So this is how you write this thing. So we say y is equal to f of x. I'm not sure if you have seen something like this, but you will keep seeing this a lot later on. The meaning of this thing is if this is how it is pronounced, y is a function of x. And what is the meaning of this? The meaning of this is there is a quantity called y which depends as a function of x. So the meaning of this is it means a quantity y. We don't know what is that y. Y could be anything. Y could be velocity or anything. Again, don't worry about writing the notes. You'll get the PDF. So focus on listening, understanding, grasp the things. That's where you spend your time. So it means a quantity y depends on quantity x. So that y can be velocity, x can be time, y can be temperature, x can be position, it can be anything and anything. So simply to put it right, this x is your input and y is your output. So anytime you see symbols like this, v of t, a of x, so the meaning of that is the quantity a is depending on x. You will keep seeing this, so you should know the terminology there. Example, and this is not the new thing. For example, if I say volume of a sphere, what is it? 4 by 3 pi r cube. But technically, you should be writing like this. The volume as a function of radius is 4 by 3 pi r cube. We used to skip the word, volume as a function of radius because we know r is the variable there. We simply write this thing as 4 by 3 pi r cube. But what it actually means is like volume as a function of r. Similarly, S of t. This is your ut plus half at square. I'm sure you have seen this equation in school. So this is actually a displacement as a function of time t. Your displacement is depending on time. So you have seen functions before, you just didn't realize like, that is what they're called as. Right? So example, more examples. So like when you say function, what can it be? It can be anything. You could take any example. Let's say y is equal to f of x. And let's say this is x square. So I have given you a function, y is equal to f of x is equal to x square. So if I put x is equal to 1, so f of 1 becomes, so you're just substituting x ka place mein 1. So that is 1 square, that's 1. If I say x is equal to 3, then f of 3 just becomes 3 square and that's 9 and so on. You can just play with this. Clear with this? Right. So if I give you one more example, let me show it in the next page. But everyone got a rough idea what is a function? So you will keep hearing these terms, something is depending as a function of that and all. So if I give you more examples, think of like this. This is the most common word, v of t, velocity as function of time t. So what happens, right, in the question, they'll say find v bracket t. They'll just write this. So you have to understand he's asking velocity as function of time t. Suppose if I write something like a of x, acceleration as function of x or position. And you can keep going on like more and more. That's it. For physics, we don't need to know more than this. So just have a rough idea. When you hear the word function, there is something of this sort. All clear with this page? Clear? So that meaning of the symbol f of x is nothing but it is a symbol of something. Now, sometimes you can even have nested functions. In your programming, ever wrote a for loop, nested for loop? You have a for loop and inside you have one more for loop. It's called a nested for loop. The same way, you can have a function something like y is equal to f of x, f of g of x. This is a function inside a function, right? So don't worry too much about this. We will see later on. So example, if someone gives you like this, let's say f of x is x square and g of x is, let's say, 2x plus 1. And if someone asks you to find f of g of 1, this is what you do. First, you find g of 1. That will be 2. So basically, you simply have to put x ka place mein 1 here. 2 into 1 plus 1, that's 3. So this becomes f of 3. So he is asking you f of 3, which is 3 square. So that's 9. So this is 9. So you keep solving one function after another function. You solve what is inside and then use that to solve the next function. Clear with this? So you can even find nested functions. You can have a function inside a function. So that's it. We just need to have this idea, like what is a function and what is the meaning of it. And we can have nested functions. You can have a function inside a function. You can have 3, 4 functions also inside. But I think you got the whole point of that. Clear with this? That's your terminology there. Great. Next thing. Now let's get back to this thing, differentiation. So what is this differentiation about? Again, don't worry too much about the whole, the thing. I want you to have some understanding. So I'm giving you some explanation. What matters end of the day is the final formulas only. When max people actually teach you, they will teach you the entire calculus for 2.5, 3 months. Right? We are just going to do this for 2 to 3 weeks. So we are doing only that stuff which is required for physics. They will do much more detailed. The calculus in physics, right? Think of it like a cute dog walking on a road. Max ka calculus is like a Godzilla roaming around and destroying the city. So that's how it will look. So anyway, so let's go ahead. So let's start with something which you already know. And from there, let's try to bring it to a context of what is differentiation exactly. But first of all, why do we need to know the differentiation? Think of like this. Imagine if you're going from your house to CST, or let's say from your house, you're going to Pune on a bike. Do you think the bike speed will be constant throughout? Some places you'll go faster, some places you'll go slower. So if you are going like that, can I say distance ka formula, right? Distance is speed into time. Can I apply this formula? Distance is speed into time. I can apply, but the problem is this. Do I know the speed? Which speed should I take? Should I take the starting speed? Should I take the final speed? Should I take the speed in the middle? You're getting the problem? Since the speed is changing at every instant, I have no idea which speed to take and how to calculate it. So I have a problem there. So when things are not constant, when things are continuously changing, it becomes difficult to handle that stuff with your regular, the regular formulas. So that is where your calculus will come into the picture, right? So let's see how it works. Whoever is this HP, please change your name and please keep your cams on. So how does this work? So let's start with something simple here. Let's take a line. So consider we have 2 points A and B. X1, Y1, X2, and Y2. So, and B. This is your X1, Y1, this is your X2, and Y2. If you take this angle to be theta, right? So this difference here, the height, delta Y, is nothing but the change in Y coordinates, Y2 minus Y1. The horizontal distance is the change in X coordinate, delta X is X2 minus X1. So this symbol delta, right, is called change. Right? So the slope of the line AB, this you studied in school, right, is tan theta, which is Y2 minus Y1 by X2 minus X1. So you can simply write this thing is nothing but delta Y by delta X. The slope of the line AB is delta Y by delta X, the change in Y coordinate by change in X coordinate. And what is theta here? Theta is the angle made by the line with the positive X axis. Clear with this stuff? Did you guys, I'm sure you learned all this stuff in school, right? The slope of a line, tan theta. In case you don't know, this is called a slope. So great. So if it is a line, I know how to find the slope. Important stuff. Just to give a little more examples, suppose if you have a line like this, and if this is your angle, 120 degrees, so be careful, the angle should be always measured with the positive x-axis. The slope of this line is tan 120 minus root 3. Suppose if the line is like this, so the angle is always measured with the positive x-axis. So let's say if this is 30 degrees, remember this is your positive x. So here the slope is tan 30. Great, you got this thing. So great, I know slope of a line. Now, instead of a straight line, what if I take a curve? All clear with this page? Any doubts on this part? I'm sure you studied this in school, but फिर भी clear with this. Tanvir, clear with this? Dhruv, clear? Ananya, Arnav, clear? Great. Now, what if I take a curve? You have taken some random curve. I have no idea. It could be any random curve. Consider a curve with points A and B. So I have taken A here, I have taken B here, and I will say, okay, these coordinates are x comma y. I'll call B as x plus delta x and y plus delta y. Basically, you can clearly see x plus delta x is the horizontal distance, delta y is the vertical distance, right? And if I try to find the slope of the line, so delta x is that only, x2 minus x1. So I'm just calling it delta x, delta y, it looks good. Y2 minus y1. Great. Now, if I find the slope of the line AB, so the formula is delta y by delta x. Great. But what does this line has to do anything with the curve? You have randomly taken 2 points anywhere and you joined them and you started calling this the slope of the line. But what is the relation? Why did you take any two random points and you draw a line? I could have drawn a line like this. I could have drawn a line like this. This line has no meaning or no sense at all. This has no relation to the curve except the thing you have taken 2 points on a curve. This line has no meaning. This is garbage. This is what happens. The same formula, when you took it for a line, it worked beautifully. You got a slope of a line. But when I tried to use this suddenly for a curve, you got something which didn't make any sense. Yeah, you took 2 points on a curve, but what does it mean? It doesn't make any sense. So there is no sense to this thing here. So, okay. So there is no sense. We can't use this. But what if I make the delta x smaller? If the delta x, which is the distance between them, becomes a little smaller. If you bring them, if you break them, meaning you're bringing them closer. So this is the curve. So now you're saying, okay, I'll bring A and B little closer. Okay, you still got a line. Yeah, still it doesn't make any sense because you got the slope of a line and still there is no sense to this. Okay, fair enough. It's not making any sense. But if you do something, if you make the delta x very, very small, meaning you bring them so close, this is how we write if delta x tends to zero. This is how it is pronounced as delta x, delta meaning change in x, tends to zero. Means you're making the distance between them almost zero, but it is not zero. Then what would happen? A and B become almost the same point. They're almost the same point. They almost meet. Means you brought it so close. And then if you try to look at the picture now, you will see something. So that random curve which you have taken and that A and B which you have taken here, now they're almost the same point. That line will touch only at one single point. If a line touches a single point on a curve, what it is called? It's called a tangent. Is that making sense? So this line AB suddenly becomes a tangent to the curve. So when you bring them very, very close, now suddenly it starts making sense. That line AB now it has a meaning. It is a tangent to the curve. It has some relation to it. So when you keep them very far, it has no meaning. When you bring them closer, there is no meaning. But when you made them the distance tending to zero, suddenly it started making sense. Is that making sense, everyone? So when you bring it very, very close, it started making sense. Now, how do you write this? Listen to this. If I write delta y by delta x, it has no meaning. But Maximum, this is how you write. Again, don't worry about this mathematical symbols. Limit, this is how it is written. Limit delta x tends to zero. So the meaning of that is when you make the distance between them very small, that's a mathematics way of saying delta y by delta x. So when your delta x is very, very small, the quantity delta y by delta x becomes the slope of the tangent to the curve. Again, don't worry about all this stuff, okay? No one, physics may, we don't need all this, but I don't want to give you formulas without having a context. So you need to have a context to what are we even trying to find. Maximum, they'll do all this stuff in much more detailed and yeah, but this is the main idea there. I'm taking slope because you already know what is a slope. Clear with this? So see, if I don't write this limit, it is useless. But the moment I put the limit, it makes sense. That part is clear with this, everyone. Now the next part. Now because we are lazy bunch, who will write this equation every time? Limit delta x tending to zero delta y by delta x. So we said, okay, let's make it look more simple and beautiful. Let's call this limit delta x tending to zero delta y by delta x. Let's start calling this as a dy by dx. So instead of writing all this term, so when you see this word dy by dx, it is understood you're talking about 2 points which are very, very close. You're talking about very, very small changes. So dy by dx is nothing but the slope of a tangent to the curve. So your slope, which is delta y by delta x, if it becomes dy by dx, it makes sense for a curve. Just to give a little more context, when you see the word delta, means it is a change, but it might be a big change. It could be, let's say, delta x is 2, delta x is 10. If you see the word small d, this means it's a very small change. But they mean the same thing. You're talking about change. Capital D is a big change, small d is a small change. If someone writes dx, it is something like 0.0000000. Yeah, something like really small. That's the kind of smallness we are talking about. You are getting very, very close to zero. More zeros you can keep, the better, right? So if you take a computer, I think it puts around like 15, 16 zeros more. So that's your whole context there. What is the meaning of dy by dx? So dy by dx simply tells you how the y changes with a small change in x. Is the whole story clear with this? So that symbol dy by dx. So what does it tell you exactly? But any doubts on this? How this thing became suddenly the slope? So meaning, if you take this angle to be theta, the slope of the tangent is tan theta, which is dy by dx. Yeah, we will see how to use that later on, but that's the idea there. Any doubts on this page? All clear with this stuff? Dave? Dave, clear with this? Dave, are you there? His cam is blank. Ahna, clear? Got this? Shrikant? Rohit? Tanmay? Perfect. Next thing. So should we take always y and x? Not necessary. Now, before that, listen to this. This dy dx is called an operator. It's a differential operator. What's an operator? Your plus, minus. If you see, those are all arithmetic operators. Plus, minus, multiplication, division, these are arithmetic operators. So what does a plus do? If you give two quantities, it adds them. What does a minus do? If you give two quantities, subtracts them. So here, be careful. Don't do such things. Don't cancel this d and this d. That's a symbol. D by dx is a whole symbol. Meaning, if I write 36 by 16, and if you cancel this 6 and 6 and call it 3, does it look like a joke? So if you cancel this d and d, I also think it's a joke. Getting it? So don't cancel that d and d. That whole thing, d by dx, is like a symbol. That's called a differential operator. And what does it do? Whatever quantity you give, it compares with x. It compares a quantity, whichever quantity you give, with x. So let me give you more examples. So for example, if I say dx by dt, x is position and t is time. So you're comparing position by time. What is this? What is change in position by change in time? Velocity. So if you compare position with time, it's called velocity. What is dv by dt? If you compare velocity with time, you get acceleration. You can even compare dt by dx. T is temperature. Like I said, you can compare anyone with anything. X is your position. There is a name for this. This is called temperature gradient. We'll talk about this later on. So the main idea is this. The reason I taught you in terms of slope is because you already know what is a slope. So it was easy for me to bring the concept from there. Clear, but you can actually compare anything with anything. Suppose if I say d work by dt, the rate of change of work, this is power. And you can keep going on. So you will see all these quantities everywhere. All clear with this? So you can compare anything with anything. It need not be always y and x. Great. Next thing. Now, a few more conventions here. So when you write y is equal to f of x, so dy by dx, now again, we are a little lazy bunch, so we should write like this technically. Y is equal to f of x and differential. So what we do for convenience, we'll just put f dash x. If you put a dash on the top, it means it's the first differential. It means differentiated once. How to differentiate? We'll be doing it. So don't worry about that. It's just a convention. Suppose if you differentiate something two times, you can do that also. dy dx of dy by dx. So differentiate once, differentiate twice. This is written as d square y by dx square. Again, this is how you write the symbol. Don't say d into d is d square. So this is written as f double dash x because you differentiated it twice. This is the second differential. Don't worry, when this comes, I'll show you again. But this is a convention. You'll see symbols like this and you'll think, what is this? So if you have dn f of x by dx power n, this is written as fn x. This is an nth differential. So if you can differentiate something n times, you might think like, sir, how can you differentiate something two times? Look at this. When you differentiated position one time, you got velocity. When you differentiated that velocity second time, you got acceleration. So if you differentiate a position two times, you get acceleration. Isn't it? You actually used it. When you differentiate once the position, you got velocity. If you differentiate it again, it becomes an acceleration. So you can have multiple differentials. All clear with this? There, that's the context of it. None of this is important for solving questions. It is just an idea. What is the meaning of a differential and what is the meaning of a slope? So that you have an idea when you are solving something, you have an idea. Okay, this is what it means, right? So blindly just remembering the formula really won't help us. Now, the next part. Now we have three set of formulas here. Now in differentiation, there are three levels. Getting it? Level one, level two, level three. So we will see the first set of formulas, the second set, and then we will see level three later on. So first thing, you have to remember these formulas, okay? We are not going to prove how we got this and everything. Max, we will take care of it. So if you have a function, and if you differentiate a function, what is the result? The first formula. If you take a constant, a is equal to constant. If you differentiate a constant, again, understand the meaning of it. dA by dx meaning how much is a changing with respect to x? If a is constant, can it change? No, therefore it is zero. So if you differentiate a constant, we get a zero. Example. If I say d by dx of 3 is a number, 0. If I say d by dx of pi is a number, constant, 0. Dhruv, UCAM is blanked out again. So that is the first thing. So if you differentiate a constant, you get a 0. The second one, you can note down these things. You will need this. So you can just put down on a paper. X power n. Important one comes a lot. dy dx of x power n. Look at the formula. It will be n into x power n minus 1. That's how you differentiate x power n there. Examples. dy dx of, let's say, x cube. Look at this formula. This is looking like x power n, where n ka value is 3. So what is the formula? N into, that is 3 into x power n minus 1. So 3 minus 1. That is 3 into x square. Let's take one more example. dy dx of root x. What is root x? X power half. So this formula is looking like x power n, where n ka place mein you have half. So what is the formula here? N into, that is half into x power half minus 1. So that would be half into x power minus half, which is 1 by 2 root x. X power minus half can be written in the denominator as root x. Are you clear with this? Don't worry, we will do a lot of practice problems, but this is the formula there. X power n ka formula is n into x power n minus 1. How we got it, we don't care. Max people will take care of it later on. Please note down the two formulas. Clear? Can I go ahead? Next thing, the third formula. Any doubts on this? So you can just note down the main formulas there. Third one, if you have a sin x, so differential of a sin x is cos x. There is nothing more there directed as cos x. A differential of a cos x is minus sin x. How we got this? There is a way to prove all this stuff. We don't need it in physics. So like I said, we will just use the results. E power x. This is a very important function. Just like pi, e is also a constant. E ka value is approximately 2.713. It is called as exponential. If you ever heard about it. If you have not heard about it, just like pi is a value 3.14 something, e is also value 2.713. It's called as an exponential. This function is cool. If you differentiate e power x, you get e power x again. So this is a function. If you keep differentiate, you will get back the same function again. 6 ln x. We pronounce this as ln x. Does everyone know a little about logarithms? Right? In Max, they must have taught something like that, ln x and all that stuff. So it's called ln x. So that much you should have an idea. In case you don't have an idea, yeah, that's a big deal. Then I'll post something on logarithms. You can check it out. I think Max people should be teaching you by now. You should ask your Max sir once. But still, I'll send you something basics of logarithm. You can check it out. So d by dx of ln x is 1 by x. These are the 6 formulas. This is level 1. You need to remember this stuff. There's nothing there to think or anything. You need to remember this. Any doubts on this? Everyone copied this? Clear? Let's go ahead with the next thing. The level 2, identities. So first we'll get used to the differentiation part and then we'll see the applications. That's where the most important thing is. Today it will be all basics only. I think maybe next class onwards. Once we start using applications, then things will be fun. So what is this identity? First thing, what if you have a function and you have a constant a into f of x? The constant can be pushed outside and then you can differentiate the function. Example, let's say we have d by dx of 3 into x square. Look at this, you have a constant into a function. The 3 can be pushed out, so then you get dx square by dx. Now you have to ask yourself, this is looking like what? This is looking like the second one, x power n, isn't it? So you always have to go back to the level 1 again. Then you will say, okay, this is looking like x square, so this is n is equal to 2. So this will be 3 into n is 2 into x power 2 minus 1. That is 6 into x. Clear with that? So if you have a constant into a function, push the constant outside and then differentiate it. The second identity. If you have d by dx of a function f of x plus or minus g of x, so f of x and g of x simply like two functions. We say, no, let the variables be x and y, like f of x and g of x. So if you have two functions, sum or subtraction, you can then just separate them separately, differentiate f of x separately, differentiate g of x separately, and subtract them or add them. Example, let's say if you have d by dx of x square plus x. So there are two functions which you are adding. You can write this thing as dx square by dx plus dx power 1 by dx. Now these formulas are looking like n is equal to 2 and n is equal to 1, which are looking like x power n. then this will be 2 into x power n minus 1, which is 2 minus 1. This will be 1 into x power 1 minus 1. That will be 2 into x, and x power 0 is 1. That's your answer. Is that clear, everyone? So you always have to go back and ask you like, okay, this guy is looking like what? It is looking like x power n, the second one. So use that formula. Any doubts on this? That's your second identity, the sum, addition, and subtraction. Yeah, next one. The third identity. This is also important, comes a lot. We call this thing as a product rule. What if two functions are multiplied? D of f of x into g of x. So if two functions are multiplied, then what you do? When you differentiate one function, let's say if you differentiate f of x, g of x will wait outside. So g of x into f of x. And when you differentiate g of x, f of x will be outside. So when you differentiate one guy, the other guy will stay outside. Example. Let's say we have dy dx of x into sine x. Now these are two functions, x and sine x. So let's call x as f of x. You can call anyone as f of x. You can call anyone as g of x. Doesn't matter. Try to put it in the formula. G of x is sine x. F of x is x. F of x is x, and g of x is sine x. Now again, going back to level one. What is dx by dx? You can clearly see dx by dx becomes 1. What is the differential of sine x? Cos x. So the answer for this thing is sine x plus x cos x. Let me show you one more. What if you have something like dy dx into cos x e power x into cos x? So these are two functions. E power x is separate and cos x is separate. Let this be f of x and let this be g of x. This is again a product rule. So g of x will stay outside. Then you differentiate f of x, which is e power x. E power x will stay outside. Then you differentiate cos x. So when you differentiate one, the other guy stays outside. What is e power x ka differential? Again, go back to level one. E power x ka differential is e power x only. What is cos x ka differential? Minus sin x. So if you take out e power x common, this ends up to be cos x minus sin x. This is called product rule. Have a look at this. This is an important one. So this is the third identity. Clear with this? You can note down the formula though. I mean, yeah, you want an example also. We're going to do a lot of problems now on this. We need to get used to this formulas and all. Any doubt so far? Anyone not clear with anything particular? Please ask. These are important. Like I said, these are the tools. So if your tools are bad, then you'll have a problem going ahead. Great. The fourth one, the division rule. This we will use it rarely, but yeah, it does come. F of x by g of x if you have a function divided by another function. So here what we do, you have to be careful which one is the first one. So the denominator will be outside first. So this order is important. You differentiate the numerator first, denominator will sit outside. Then the numerator will be outside with a minus sign, and then you differentiate the denominator. So unlike the product rule, you can't take anything as anything. You have to be clear with this. Divided by the denominator a square. Yeah, it looks more complex. This is a division rule. Example. Let's say dy dx of sine x by x. So it's a function by a function. Sin x is f of x. X is the denominator is g of x. So if you apply this in the formula, you end up with x differential of sin x, and your f of x is sin x differential of x by g of x will be x square. And then simplify this. Sin x ka differential is cos x. And dx is 1. And the denominator is x square. So this would be x cos x minus sin x by x square. These are the 4 identities. So there, the standard results and 4 identities, total 10 things. So this is your level 2. You should be thorough with this. So if you're thorough with level 1 and level 2, level 3 becomes very easy. Level 3, we call it as a chain rule. So we'll see that later on. So let's work on these things for some time, and then we'll see some applications, and then we'll go ahead. All clear with this? Clear enough, Karthik? Manav? Arnav? Clear? Great. So now I'll give you some questions. You guys have to solve and get the answer. You can just finish it off like it, let's say x power 4 d by dx of x power minus 3 by 2 d by dx of x square plus 3x d by dx of x square plus 1 ka whole square d by dx of sin x plus cos x d by dx of sin square x secant x d by d of e power 2x. Let's get these 10 questions. You just need to check which one belongs to level 1, which one is looking like level 2, and then use the appropriate formulas. Give it a try. It's okay to get a wrong answer. Do whatever you think, right? When I show you, you can verify whether you got it right or wrong. You understand, great. You don't understand, ask me. I'll help you out there. But the best way to learn is to give it a try, and it's fine if you do a mistake. Whatever you remember with the 6 identities, I hope you note it down. So you need to write it down. So you need to refer back in case you forgot. And the 4 identities. So please don't think like, my memory is so strong, I will remember everything. Don't trust your memory. As things go on, right, the things will become so complex and everything, your memory will start deceiving you. Always put it on a paper. It helps. Get them all. Then, yeah, easy stuff. So if you have already done in your classes, then it's fine. If you're not done, this is the first time, it's fine. Take your time, get it done. The first 3 are straightforward. I'll keep showing them once every 40 seconds, 30 seconds. I'll show one. So keep going. Again, don't write the question, don't do anything. Just solve. Take a paper and just solve it. Maintain a rough book because you'll get the notes. I'll send you the PDF. So don't waste time writing each and every question. Yeah. Okay. The first one, this is looking like x power n, where n is equal to 4. So the formula is n into x power n minus 1, which is 4 into x power 3. This is n is equal to minus 3 by 2. So later on, I'm not going to write all this. You have to get used to it. You can see the thing and should tell the answer, maybe not today, maybe next week. So this is n is minus 3 by 2 into x power minus 3 by 2 minus 1. This is minus 3 by 2 x power minus 5 by 2. You can leave the answer like this. If someone didn't get something here or not here, please ask. You can just please always unmute and ask. So don't hesitate, get it cleared. This guy is looking like f of x plus g of x. The identity is second one. So I can write this thing as d by dx of x square plus d by dx of 3x. Right? So this can be written as x square ka differential. Again, now look at this thing. This is looking like x power n. So this is n is equal to 2. So this would be 2 into x power 2 minus 1 plus 3 will come outside. This will become dx by dx. And dx by dx is 1. We can check it out. So dx goes off. This would be 2x plus 3. This thing, you cannot do this directly. There are ways to do, but not today. This would be expand this a plus b whole square, x power 4 plus 2x square plus 1. Now this is looking like f of x plus g of x plus h of x. So differentiate each term separately. D by dx of x power 4 plus 2 is a constant. 2 comes out. D by dx of x square plus 1 is a number. So d1 by dx. X power 4. N is 4. So 4 into. So this is n is equal to 4 and this is n is equal to 2. They look like x power n. So this is 4 into x power 4 minus 1 x cube. This is 2 into x power 2 minus 1. And a differential of a constant is 0. This is 4x cube plus 2x. Please check your answers. Anyone confused with ABCD? Yeah, I think people did get the others. Yeah, that's okay. Some of you already know. I think must be done in your classes. So, any doubts on ABCD? Arnav, clear with this? Tanvir, Tanmay, Radhika, clear? Ahana, Dave, clear? What about the other parts? E is looking like what? F of x plus g of x. So this can be written as dy dx of sin x minus dy dx of cos x. Sin ka differential, cos x. Cos ka differential, minus sin x. So this would be cos x plus sin x. So how do we handle sine square x? That I didn't give you. Yeah. X into e power. How do you handle sine square x? I didn't teach you sine square x.
Can we take it as sin x into sin x?
We have to use a product rule. So we can take sine square x as, so I will just. So what I can do, I can write the sine square x as sin x into sin x. I can use my product rule. Like I said, there are better ways to do this, but yeah, that's level 3. We'll see later on. So sin x into sin x. So you can write this thing as f of x, and you can write this thing as g of x. And then I can use the formula there. So this would be sin x, differential of sin x. The other sin x will be outside, then differential of sin x. Sin x ka differential is cos x. This would be 2 sin x cos x. And I hope you remember the formula. 2 sine A cos A is sine 2A. That would be your final answer. So yeah, 2 sine A cos A is sine 2A. Same thing you can do for the cos square x. So dy dx of cos square x is cos x into cos x. We repeat the same story there. So we get cos x differential of cos x. Cos x differential of cos x. Cos ka differential would be sin x. Then that would be minus 2 sin x cos x. And sin 2a would be minus sin 2x. Any doubts on f and g? Shrikant, clear with this? Done. Tanmay? Radhika? Clear? Dave? Clear? Ananya? Manav? Clear? Prisha? Clear so far, right? Done. The next thing. We still have tan x. How do you do tan x? Dave, what do you think?
Sin x by cos x.
Perfect. We have to use the division rule. So this can be written as d by dx. Tanvir, clear so far? This is sin x by cos x. So this would be your f of x. This would be your g of x. Do you remember the division rule? G of x differential of f of x minus f of x differential of g of x by x square by g of x whole square. Substitute there. G of x would be cos x. Differential of this thing is sin x. Cos x differential is sin x by cos x ka whole square. Yeah, little lengthy, but it's a good result. I remember tan x ka differential. We use that again later on. So sin ka differential is cos x minus sin x. Cos ka differential is minus sin x by cos x whole square. So numerator, if you see, it becomes cos square x plus sin square x, which becomes 1. So this is 1 by cos square x. When it goes up, you end up with secant square x. Yeah, exam, you won't have time to do all this thing. So remember, tan x ka differential is secant square x. Helps, it comes a lot. What about secant x? Same thing. Secant x can be written as 1 by cos x. That's d by dx of 1 by cos x. So we can do the same story there. This would be your f of x and g of x. Differentiate this. You should get an answer secant x tan x. I will leave it to you. Figure it out. You couldn't figure it out? Let me know afterwards. What about e power 2x? E power 2x can be written as e power x into e power x. Again, a product rule. E power x will be outside. You differentiate the e power x. The other e power x will be outside. You differentiate the e power x. This would be e power x into e power x plus. That's 2 times e power 2x. Yeah. All clear with this. If you understood till here, your level 1 and level 2 are good enough. All clear with this? Now in the exam, no one will ask you these questions directly. How will the questions be framed? Let's see one more. Can I go ahead? Any doubts so far? Anyone not clear with anything here? Not convinced with something? Please ask. Shrikant, Tanvir, Arnav, clear? Radhika, Ananya, Dave. Perfect. Let's see a question. Let's say we have a parabolic mirror. So this is called a parabola. It looks like this, a parabolic mirror. The equation of this mirror is y is equal to x square. So someone constructed a mirror which is in a thing. It's a parabolic mirror. This is your x and y axis. Now what you did, you sent a light ray horizontal to the x-axis. So this is a horizontal light ray. When this light ray goes and hits the mirror, it bounces off and becomes vertical. This is a vertical reflected ray. Now understand one thing, this does not happen every time. For example, if you take a mirror like this and if you send a light ray, if you're hitting somewhere here, the light ray can become like this. If you're hitting somewhere here, the light ray can become like this. So it does not become 90 every time. This happens for a specific point P. So only when you hit the light ray at a point P, it becomes vertical, right? So a horizontal light ray hits the mirror and becomes vertical. Find the coordinates of point P. This bottommost point is origin. The horizontal ray hits the mirror and becomes vertical. So at which point should you hit on the mirror so that this becomes vertical? Think for a minute. I'll show you one, then I'll ask you one more. Yeah. Don't feel like, oh, what the hell and all. Just think, take for a minute and just think like, okay, how do we even approach this? What did I teach you so far and what did I ask you? They look like completely two different things. Nee, Rohit. We have one answer, so that's not the answer. You have to tell me the coordinates, Rohit. Numbers आएगा. X comma y coordinate, isn't it? So let's see. Anish got an answer. Others, try. I'll give you a minute. Don't worry about that. You take your time. You figure it out. Anish, in the meantime, you can do this thing. What if the light ray goes here and becomes 120 degrees? You do for 120 in the meantime. हना माइनस n कैसा है कह रहे हैं? ये तो फर्स्ट क्वाड्रेंट है. What is that, Rohit? 2 is what? X coordinate or y coordinate? Okay, listen, I'll show you one model. So what is happening with the whole story there? The first thing, when you have this curved mirror, from principle of reflection, so when the light ray hits here and bounces here, great. First thing, draw the normal. This is my normal. Now for the normal, if you draw a perpendicular, you get a tangent. This line is my tangent. Everyone agrees with this picture? So you draw a normal and you draw a tangent. Now from principle of reflection, if the whole angle is 90, I is equal to R, this angle must be 45 and this angle must be 45. Agreed? If these two are 45, then this angle is also 45. Why? Because tangent and normal are 90 degrees. That means your tangent is making an angle of 45 degrees with the horizontal. Make sense? So I used principle of reflection to find the angle made by the tangent. So tangent at point P, not any tangent, it's a very tangent at point P, makes an angle 45 degrees with x-axis. Great. That means the slope of this tangent at point P is tan 45. But we also know from calculus, slope of a tangent is nothing but dy by dx. So dy by dx is tan 45. But it is given in the equation y is equal to x square. So dy by dx is nothing but 2 times x. This is the x power n ka formula. So I got 2x is equal to 1. So I got x is equal to half. If I substitute x is equal to half, then y will be half square, which is 1 by 4. So the coordinates of point P are half comma 1 by 4. Did we see how we played around? So we started with your optics, right? Law of reflection. We got the angle. And then we said, this tangent here is making 45 degrees. But from calculus, we also know this tangent is nothing but dy by dx. I hope you're getting it. So this is how you will connect calculus to something else. No one will ask you the calculus question directly. It will be related to something there and it will be like a tool in the middle. Anish, right. Yeah, right, Prisha. Everyone clear with this? Is this making sense? Now tell me one thing. Is the differentiation difficult? No, right? The differentiation is actually easy. This is what will happen in physics. The calculus part is actually easy. The headache is converting a problem into an equation and solving is the headache. Now, same logic, can you do for this guy? Since you understood this, let's do the same thing. Let's say y is equal to x square. I'll keep it same, but this time the ray hits the mirror and it bounces off like this at 120 degrees. Let's call this point Q now. Can you find the coordinates of Q? Get it. I'll give you a minute. I showed you for 90, right? You guys give it a try for 120. Right, Karthik. Right, Rohit. Great. You will get this thing. So let's take a break. Once after the break, we'll continue with this thing. Come back by 9:45. 9:36. Come back by 9:45. We'll continue from here. Any doubt so far? Chill. Come back by 9:45 then. Go. Get away from the screen for 4-5 minutes then. Maybe you can try after that if you want. So let's start off. So step one, what we do, we draw a normal. Then we draw a tangent. The angle between tangent and normal is 90. So this angle was 60 and this angle was 60 because I is equal to R and the total angle was this. And this angle was 30. That means your tangent is making an angle of 30. Then you're done. So slope of the tangent is tan 30. But slope of the tangent is also dy by dx. That came from calculus. Tan 30 is 1 by root 3. Y is nothing but x squared, so dy by dx is 2x. So x is equal to 1 by 2 root 3. Substitute there, you end up with y is equal to 1 by 12. Clear this. That's how you can figure out your coordinates. So please check, see where it went wrong in case you got it wrong. Anyone is confused with this, please ask me. Others do keep your cams on. Clear? Let's see one more like this. Let's say you got a mirror like this, a sine mirror. A little more about this thing, right? This thing which we drew here, 90 degrees, it actually doesn't happen at a single point, you know. If you take it a 3D thing, if you actually consider this in a 3D shape, all these points on this circle, so anything that hits here will actually go down. So you actually get a full circle there at that radius. Anything that hits at that point, right, all the light rays hitting that circle will go down. In 3-dimensional, we call this thing a paraboloid. A parabola is a 2-dimensional thing. A 3-dimensional thing is called a paraboloid. This is how it would look. Interesting shape. It does come few times later on. You'll see. There. So this is a 3D ka thing. You know how this thing looks like? Did you ever see Enfield ka headlight? If you ever seen Enfield ka headlight, it looks like this. It's actually a paraboloid. You know where else you see this? If you take a bucket of water and if you rotate the water, or if you take a glass of water and rotate it with a spoon, the shape of the water, what you get is actually a paraboloid. So a rotating water in a bucket or a glass, the shape it forms like a bowl. It is not a semicircle. It's actually called a paraboloid. You can see this thing. This is a rotating water. You get a bowl shape. So these are 3D shapes, the paraboloid. So a paraboloid, right? You'll get actually full circle. Anywhere you hit on the red circle, the light ray becomes vertical. So yeah, that little context there. That's a 3D may. Let's say we have a mirror. The equation of the mirror is y is equal to sine x. So someone took a mirror, y is equal to sine x, and you created it. So this point is your origin 0, comma 0. At this point is your coordinates pi, comma 0. Look at this. If you put x is equal to pi, I get sine pi is 0. Now this light ray hits some point on the mirror and bounces off like this. And this angle is phi. And the coordinates of this point P, now it is reverse. I'm giving you the coordinates. The coordinates of this point are 2 pi by 3, comma root 3 by 2. Find phi. So I can play the other way around also. I'll give you the coordinates and ask you for the angle. So horizontal ray hits a mirror and bounces off at an angle phi. P is the point where it hits, and the coordinates are 2 pi by 3, comma root 3 by 2. 2 pi by 3, comma root 3 by 2. Then find the angle phi. You won't get any standard angle. You'll get something like tan inverse something. It's okay. That's how you can represent it. Let's get this. So these are all our applications based on calculus and light, ray optics we call it. So ping, ping, ping. A little more mathematically, a little weird. Like the idea is still the same. You have to use little geometry. Figure it out. I'll give you another 1-2 minutes and then I'll show you. It's completely fine if you don't get it. Don't worry about getting an answer. I want you to think. As long as you're thinking and figuring out and trying to do, that's important. You will figure out eventually. Getting a wrong answer is also completely fine. I don't think so, Rohit. That looks wrong. I don't know the exact answer, but that looks wrong. Let's see if anyone got the same thing. But check your answer again. Tan inverse 3 root 3 by 4 pi 2 cot inverse minus half. That looks right, I guess. True, insert the value of x or something. Yeah, you have to figure it out. You can't ask me like, oh, we have to do that. I give you 1-2 minutes to figure it out. I'm going to show you anyway. Okay, let's see. Let's put some geometry there again. So first thing, let's put a normal. If you see, the story is still the same. Right? So draw a normal. This angle will be phi by 2. This angle will be phi by 2. That came from incidence is equal to reflection. And from here, draw a tangent. Remember, this angle will be 90. And you can clearly see this line here. And if you draw a horizontal line, both are parallel. So let's construct a triangle between these 2 points here. This angle also must be 5 by 2. Agreed, everyone? And this angle was 90. If that was 90 and this was 5 by 2, then this angle would be 90 minus 5 by 2, because the total sum must be 180. That means this angle must be 90 plus 5 by 2. All clear with this so far? This angle is 90 plus 5 by 2. So meaning your tangent here, this was your tangent. Your tangent is making an angle of 90 plus 5 by 2 with your x-axis. The slope of this tangent is tan of 90 plus 5 by 2. Clear with this? And tan 90 plus 5 by 2 is nothing but minus cot 5 by 2. I hope you know that. In case you don't know that, don't worry, right? Max may they will teach you in trigonometry. That will be the starting part. Tan 90 plus theta. Did you guys study anything like that in school? All silver teacups, they teach you something like that. So it's fine. If you don't know that, that's okay. If you got till 90 plus 5 by 2, I think our job's done. But we also know what the slope of the tangent, dy by dx. Great. So we got the slope as minus cot 5 by 2. And what's dy by dx? Y is equal to sine x. So if you differentiate that, so let me show it in the next page. So we know y is equal to sine x. And dy by dx is equal to cos x. And you're saying this is nothing but minus cot 5 by 2. And what is cos x? X ka value is given, right? The coordinates are given, 2 pi by 3 and root 3 by 2. At point P, x is given as 2 pi by 3 or 120 degrees. Cos 2 pi by 3 is minus cot 5 by 2. Cos 2 pi by 3 is minus half. You should remember that. And this is cot 5 by 2. So we get cot 5 by 2 is equal to half. Or you can also write this thing as tan 5 by 2 is equal to 2. You can write however you want at this point, right? It all depends on how the options are looking. Did they give options in tan or cos? You check it out. Why did you choose 90 plus pi by 2? And God, this whole angle has to be 180, right? If that whole angle is 180 and if this angle is 90 minus 5 by 2, this should be 90 plus 5 by 2. And how is that slope ka definition? You're not there in the beginning, yeah? We wrote that only story. The slope is defined as the angle with the positive x-axis. We always take that angle with the positive x-axis. Right, Dhruv? Yeah. So, and then you're done. You can send the tan that side. So in case you don't know about these things, they're called inverse trigonometric functions. Don't worry too much. It's just a way of writing, that angles, like when the angles are not standard. You can write this way, or you can write even in terms of cot also. That also works. So we get phi is equal to 2 times cot inverse half. Now, both are right. Nothing wrong with that. It all depends on how are the options looking. Are the options in cot? Then write in cot. If they're in tan, write in tan. So there is more of a mathematical things, but I feel the most important thing was getting this angle. If you got this, I think you got it. Everything else will just finish it off. All clear with this? This one way of asking. Another way of asking. Let's say if x is your position, a little theory before we go ahead. So velocity v, Tanvir, you're saying something? So velocity v, Tanvir. Tanvir, you're saying something? No.
No, I was talking to my mom.
Okay. So velocity v is dx by dt. So if you differentiate x once, you get velocity. What about acceleration? A is nothing but a change in velocity by time. This thing can be also written in another form. Look at this. dv by dt multiply and divide by dx. Then your dx by dt becomes velocity. So this can be written as v dv by dx. So for acceleration, we have two formulas, everyone. Either you can use dv by dt or we can use v dv by dx. So when to use which one? Use this if v is given in terms of t. Both are right. It is just that the variables are different. Use this if v is given in terms of x. That you can note down these things if you don't know. That's straightforward. So this is based on calculus and motion in a line. So let's see how they'll frame questions on this. Like I said, every time, right? You need not differentiate every time with x. You can differentiate anything with anything. All clear with this? Can I go ahead? Let's see a question on this then. So let's say x is equal to t cube by 3 minus 3t square plus 2t plus 1. X is the position, t is the time. Find velocity and acceleration at t is equal to 1 second. Let's get this. Again, remember what is v? V is dx by dt. So differentiate once and then put t is equal to 1. What is a? dv by dt. So you have to differentiate whatever you got again. Take a minute. I'll show you this again. Okay, we have Rohit, end may have to substitute 1 in the answer. Okay, Anish, that looks right. Prisha, that looks right. Karthik looks right. Okay. Try others. I'll give another 30-40 seconds. So then I'll show you. It's completely even if you get a wrong answer. Don't think too much about that. You just try to figure out like. Be careful, huh? Don't substitute the number and then differentiate. You should always first differentiate and then end way you have to keep. The t is equal to 1 has to be kept in the last. Okay, let me show you one. See. So you want to find velocity? V is equal to dx by dt. So there are 1, 2, 3, 4 terms. So you can differentiate each term separately and add them. This is f of x plus g of x. So this is d by dt. So 1 by 3 is constant. It comes out. You should get used to this thing. Huh? You should be able to see this and write it down later on. 3 comes out. Differentiate with t square. 2 comes out. Differentiate with time. And 1 is a constant anyway. T cube का differential 3t square. T square का differential 2t. dt by dt is 1. Constant का differential 0. So velocity v is nothing but t square minus 6t plus 2. What is the acceleration? Differentiate the velocity again. So you have to differentiate this stuff again. That's dt square by dt. 6 will come out, dt by dt, and 2 ka differential. Please ask me, anyone is not clear with something here. This will be 2t minus 6. So there, you got your acceleration and you got your velocity. So you got velocity is t square minus 6t plus 2. This is the velocity as function of time t. But you want a t is equal to 1. So just put v is equal to 1 there. So that will be 1 minus 6 plus 2. That would be minus 3. Acceleration is 2 minus 6. So put t is equal to 1. So that would be 2 minus 6 minus 4. Is that clear, everyone, what we did? So differentiate once, differentiate second time. When you're differentiating, you can clearly see this is looking like x power n and looking like f of x plus g of x. Clear? So like I said, differentiation is just a tool. That's not a question. Any doubts on this? I think most of you did get it. Yeah, you can say that through. Tanvir, clear with this? Ahana, Anish, Dave, Manav? Perfect. Now let's see one more. Let's say x is equal to t cube by 3 minus 5t square by 2 plus 60 plus 2. Find velocity when acceleration is 0. This is a different way of asking. So he's asking, find the velocity and acceleration is 0. First, you have to find when is acceleration is 0. You'll get time from there. Use that to substitute in the second one. Same thing. We are just switching the question front and back. Okay, someone got something. Let's see. It looks right. Okay, let's see. So step one, let's differentiate it. There's no way out. You have to find the velocity. So velocity is dx by dt. T cube ka differential, 3t square. 3 will cancel, t square. So I'm writing it directly now. T square ka differential, 2t. So that is 5t. 60 ka differential, 6. Great. Acceleration, differentiate the velocity again. T square ka differential, 2t. 5t ka differential, 5. Great. Now he's saying acceleration is 0. So when a is 0, 2t minus 5 is 0. We got the time is 5 by 2. So indirectly question ye ho gaya. Find the velocity when time is 5 by 2. You getting it? That's what is being asked. Because at 5 by 2, you're getting acceleration is 0. So take this and dump it in the velocity. So now take this 2 and put it in this thing. So 5 by 2. And this would be t cube by 3. And numbers are bad. 5 by 2 whole cube by 3. No, sorry, I had to put in velocity, right? So that's t square minus 5t plus 6 That's 5 by 2 whole square minus 5 into 5 by 2 plus 6. That's 25 by 4 minus 25 by 2 plus 6. And that's, I think it's minus 1 by 4. Yeah, most of you did get it. Yeah. All clear with this? Please check your calculation, see where it went wrong. You have to differentiate it twice, and then we have to get the time from there and put it here. Any doubts on this? Great. Let's see one more. Let's say x is equal to k into 1 power e power minus bt. So you need to get used to the variables. So here k and b are constants. So k and b are some numbers, maybe 2, 4, something of that sort. Find initial velocity and initial acceleration. Again, this is some new word. So what do you mean by initial? Initial meaning time 0. So they won't say that. They won't say find at t0. They'll simply say initial. So remember that thing. Whenever they use the word initial, indirectly saying when time is 0. Answer will come in terms of k and b. So that is one more thing. We will actually later on as time passes, right? We stop using numbers a lot. We use more variables. Because when you have variables, you can modify them and you can see how things are working. BKE पर नेरे अनिश ने ध्रुव initial t0 डालना है end में. That might be right. And be careful, huh? Don't substitute and then differentiate. You have to finish your differentiation completely for B and A, and then end में you have to keep it. Prisha got something. I think that looks right. Others. Ahana got the velocity part right. Dhruv, that is not right. Anishi got the velocity part right. Get the acceleration also. Get me both. Give me both the answers together. Right, Karthik. We have two answers. Everyone should try. Everyone should try. I'll give another 40 seconds. There is one more level of differentiation called chain rule. I don't want to do that today. Like, I wanted to get used to this one level, and then we will go too much on one day, right? If someone is listening for the first time, it will feel like a lot of mess. But I think some of you do know. It's okay. That is fine. नहीं आया ना already done that. Let's see. Let's differentiate this. So this is like what? K into 1 minus e power minus bt. So when you differentiate this, so let's write like this thing. K into k e power minus bt. I know it's a lot of variables. It looks really weird, but yeah, this is something you will get used to it. So dx by dt, when you differentiate this, so first differentiate that constant dk by dt. Remember, k is a constant. It's like a number. You can push it outside. D by dt e power. Oh shit! Wait, I didn't teach you this. Some of you know this thing. This thing is actually based on chain rule. That's why some of you are struggling. My mistake. I'm sorry. You can't do this right now. That e power minus bt, I need to teach you chain rule. But if you already know chain rule, you guys did it. That's based on chain rule. Sorry. I wrote only e power x. Forget about it. We'll come back to that question later on again. I was wondering why some of you are struggling. Yeah, the answer is right though. Answer was KB and minus KB square. These are the answers for velocity and acceleration. If someone still got it, that's how you do it. Okay, that is one thing. And there's a chain rule. We need to do that also. Next thing, what happens if you differentiate a vector? Now we are combining the last chapter with this. So if you have a vector A bar, which is AX I cap, AY j cap, and AZ k cap. So if someone asks you to differentiate a vector, again, same thing. Nothing new. You just differentiate each coefficient separately. So differentiate x ka coefficient dAx by dt I cap. Differentiate your AY coefficient dAy by dt j cap. And differentiate your AZ. So dAz by dt k cap. That's it. Nothing new and all. You just differentiate the coefficients. So example, let's say A bar is given as t square I cap plus t j cap plus t cube k cap. Hope you guys remember the vectors. Now if I ask you to differentiate this dA by dt, t square ka differential is 2t I cap, t ka differential is 1 j cap, t cube ka differential is 3t square k cap. All clear with this? So that's how you handle this. If you had differentiated a vector, you just differentiate each coefficient and finish it off. So there's nothing big deal about it. Clear? Let's see a question. So let's say I give you a velocity vector. Let's say position vector only. Let's say the position vector, we'll call it R bar. T square I cap plus 1 by t j cap. Find velocity and acceleration vector. So basically the I cap and j cap are directions. They don't change, so they will just remain there. Vector at t is equal to 1. There, let's get this. Yeah, right, Ahna. That previous one was right. No, I was wondering, e power minus bt. I didn't teach you that. I thought I finished it. My mistake. We'll do it in the next class anyway, don't worry. I will modify that question more. Tanvir, you know vectors, right? Then it is fine. This is what will keep happening. Every time I teach you something, I'll keep adding it for the next chapter. So when I teach you the 14th chapter, I'll use all the 13 chapters. Physics ka, that's a big advantage and a big headache also. Advantage because if you're thorough with your topics, you will love physics and things will be very easy and you will do really good. But if you don't revise on time and if you don't study thoroughly on spot, then you'll have a problem. The backlog will just keep piling up. You won't have that issue in maths. Like you don't know matrices, you can study vectors. You don't know vectors, you can do calculus. Physics, unfortunately, it messes up. Let's see. So you want velocity vector? dr by dt. So what to do? Differentiate each coefficient separately. So t square ka coefficient is 2t I cap. And what is 1 by t? That is t power minus 1. So maybe if you want, I'll write it down once. this would be 2t I cap, and this would be t power minus 1 is 1 by t square j cap. That's your velocity, everyone. What's the acceleration? Again, differentiate it. That would be 2 I cap, and what is minus 1 by t square ka j cap? That is t power minus 2. So that would become plus 2 by t cube j cap. Please check. If you're confused, please ask me on this. And once you got this, now you want to put the time t. So at t is equal to 1, v bar will be 2 I cap minus j cap. You want to put acceleration 2 I cap plus 2 j cap. Yeah, check your answers. Be careful with I cap and j cap there. Yeah, great. Any doubts on this? Okay. Yeah, I think that everyone got it. Rohit, clear, na? Got it. Let's see one more. Let's say the velocity vector v bar is t square I cap plus 1 by t j cap. Find the time when acceleration and velocity are perpendicular. Find time when the acceleration vector and the velocity vector are perpendicular. Let's see, Anish. I don't remember the answer. That might look right. Now see what I did. I used calculus, I used vectors, and I used dot product. You can see how things are going on. We are just combining everything now. You heard this word, right? Whenever you hear the word two vectors are perpendicular, means what? The dot product is 0. So find A, find V, and then do the dot product and equate it to 0. Let's see. So first thing, the acceleration, you differentiated once, which is dv by dt. T square ka differential is 2t I cap. 1 by t ka differential is 1 minus t square j cap. Since the acceleration is perpendicular to velocity, a bar dot v bar must be 0. And I hope everyone knows how to do the dot product. Multiply the I coefficients, which is t square into 2t 1 by t into minus 1 by t square. This must be 0. Then you end up with 2t cube by 1 minus t cube is equal to 0. This would be t power 6 is equal to half. So the time will be half to the power of 6th root. Clear what we did? So when you differentiate, you got the acceleration. Then you said both are perpendicular. That means the dot product must be 0. Any doubts on this? I hope you can see this thing, right? How we are playing around with things. We are connecting stuff. So your dot product should be there. Your vectors you should know. Differentiation you should know. We can do more complex things. We can do more variations of this. So I think next class we will continue with this, right? So when we catch up on next Monday, we will work on this. Vectors is done. So, and like I said, this Saturday the test will be online on basic math and everything. I'll post it once it is online, so you can start doing it. The next class when we catch up, we will do something called chain rule. We'll do a little more higher level, but the idea is still the same. I will teach you one more technique for differentiation, right? And then we'll do more equations based on this acceleration, velocity, and all the stuff we'll play around with this. And then we'll do something called maxima, minima. That's more important. And we will see that. Okay, with that, we'll wrap up for the day. So I'll see you guys again on Monday. So any doubts, anything else, please stay back and ask. The test is only for 1 hour. It is just a physics car test, right? So the test is for 1 hour. It will be 25 questions. The marking scheme is +4 and -1. If you get the answer right, you get 4 marks. If you get an answer wrong, you'll get a -1. If you don't mark the answer, you will get a 0. And the timer starts once you start the exam. Yeah, it is just like the sample test, right? So there are papers there as a sample test. You can check it out and see how it works. Oh, theek hai na re Dhruv. When it comes, you will know. So yeah, that's it. This thing will be all mains test is only +4 -1. So yeah, once you read 1 or 2 tests, you'll get the hang of it. Okay. If you have any other questions, any queries, please stay back and ask. Also free to do. I'll see you guys again on what is today? I'll see you guys again next Monday, same time.